Now I'm gonna work through these pretty quickly because I think everybody knows what to do, but not everybody is writing down every step. Okay? And as soon as you skip a step, there's a strong tendency to make a mistake. So we want to make sure we write out every step. So we got 3x equals 5. What do? Well, 3 is multiplied by x, so we can isolate x by dividing both sides by 3. And we get x equals 5/3. Now, I'm not going to go through the check, but it will say if x is 5/3, then what's 3 times 5/3? Well, this 3 will divide that 3 and you'll end up with 5. It's very straightforward to check it. But you want to be sure you always include the check. And even if you're making mistakes, I see that everybody is checking. And that's really good. Okay, now we've got to see, because most of you made a mistake at some point or another. And the check didn't work out. Okay, so let's try 2x plus 7 equals 3. And we subtract 7 from both sides. So we got a plus 7 here. Then we want the numbers over here and the x terms over here. So we have this. And 7 minus 7 is 0. 3 minus 7 is 4. So we don't need to write the 0 that we get for 7 minus 7 here. So we get 2x equals 4. Then 2x divided by 2 equals 4 divided by 2. So that x equals 2. Now again, we checked that and, I was really careless. X minus 4. 3 minus 7 is negative 4, right? Because I was about to check it with x equals 2. 2 times 2 is 4 and add 7, we get 11, we don't get 3, right? So as soon as I looked at that, I knew I'd screwed up something here. So it's pretty easy to see because there's just a little bit of arithmetic involved. And now if we put in negative 2, we get negative 4. 2 times negative 2 is negative 4. We add 7, we get 3. So the check works out just fine if we do that. Okay. Now we have 2 times the quantity x minus 4 equals x minus 3, sorry, equals 3 times the quantity x minus 4. And we use the distributive law. We get 2x minus 6 equals, and I'm going to write out just a little extra here, okay? Because what we're going to do next. You'll see what I mean in a minute. As long as you multiply the 2 by the negative 3 and get that right, it's okay. But I'm going to write it out literally. This gives us 2x minus 2 times negative 3. All right, 2 times 3 equals 3x minus 3 times 4. Okay. Now that's going to be an important step when we do this with symbols, because I'm going to do an equation like this with symbols. When you got numbers, of course, it's easy enough to go ahead and multiply the 3 by the 4 and make it with the negative on it. Okay, then we have a choice. We can subtract the 3x from both sides, get all our x's over here. Then we can add 6 to both sides, get all the numbers over here, and we'll be good. Or we could add the 6 first and then subtract the 3x next. So let's see. How many want to subtract the 3x? Give me a thumbs up. How many want to add the 6 first? Man, it's a tie because one of you didn't vote. You got to vote. Up or down, doesn't matter. Okay. Okay, so we're going to subtract the 3x from both sides. And sorry for anybody to wanted to add the 6. So we got a 3x here and a negative 3x here. Next is going to leave us to 12. We got 2x minus 3x, which is negative x. And we still got the minus 6. Okay. And then we add 6 to both sides. And we get negative x equals 18. And then we multiply both sides by negative 1. Okay. Now write that out. And that changes the sign of both of each side. Now you can, it is legal to just change the sign of both sides, but the step, the official step is you multiply by negative 1. Okay. So you can kind of skip that step as long as you're not making a mistake. And then let's see if that checks out. Let's see, we get negative 21 here, and 2 times negative 21 is negative 42. And here we get negative 22, and 3 times negative 22 is negative 66. So it seems that something may be wrong here. Let's write that out carefully. Let's see, negative 18 minus 3, yeah. And negative 18 minus 4. And it is 3 minus 4. So what I do wrong, got to go back and check. And having written out every step, it's somewhat easier to do that. 2x, 2 times 3, yeah. We got 2x, we got minus 6. And 3x minus 3 times 4, 3x minus 12. No problem there. Oh, you know what? No. Yeah. You know what I did here? Well, actually, I did. It's supposed to be minus 12. I forgot a minus sign again, right? Real easy to do that. So let's see, let's correct it. We've got minus 12 here, minus 12 here. That would be minus 6. We end up with x equals 6. Okay, let's see if I got it right this time. 6 minus 3 is 3, and 2 times 3 is 6. 6 minus 4 is 2, and 3 times 2 is 6. We get 6. So I'll just say the check. And I just said the steps there because y'all know how to substitute. And you probably know better than I do how not to miss a negative sign. Okay. Now, that's not even the problem I wrote down. Where'd that come from? That should be 4 times x minus 3, but matches the problem. Okay. But the steps are identical, so I'm going to kind of leave that alone. I'm just going to change the problem retroactively. And there it is. Okay. Now, two times x minus 4 equals 5. Well, we use the distributive law. We get 2x minus 2 times 4 equals 5. 2x minus 8 equals 5. Then we add 8 to both sides. We get x equals, well, two x over 2 equals 13 over 2. X equals 13 halves. You write that as 6½ if you like, but usually if we're doing the arithmetic, we want the improper fraction. Now, 4 is 8 halves. You subtract that from 13 halves, you get 5 halves. And 2 times 5 halves. 2's divide up, and you end up with just a 5. So that checks. Okay. Now, I think y'all are gonna be okay with linear equations, which will be due for class, well, tomorrow night. Okay? Because I think most of you are doing most of what that set asks you to do. Okay? You got the basis for it. You learn a little bit more, open baffle, a few little blanks. But I think you're gonna be fine with that. So. Okay. You leave this up here for a minute. Okay, so let's say we have an equation like AX equals B. I'm gonna give you a couple of minutes to see if you can figure out how to solve this. What are your steps gonna be? And what are you gonna do with those letters? We're gonna do the same thing with those letters you do if they were numbers. Okay? In other words, if this is 3x equals 5, then A could be 3 and B could be 5. And what do? We divide both sides by 3 and we get our answer, right? So you can kind of imitate what we do here, but use the letters, see what you get. Okay, I should have been clearer. When I said, here's what we do with the numbers, and I said, now do the same thing with the letters. Now, some people misunderstood that and naturally enough went ahead and say, okay, A equals 3, B equals 5. So now we just solve the equation we already solved. Okay, and that's good in itself. But what we really mean to do here is this. A is multiplied by X. So if we divide both sides by A divides the A and gives us 1. And we could say that's 1x. But we kind of understand that A divided by A is 1. So we probably don't write out that step, although it doesn't hurt. I'll kind of put that step in parentheses. That's something you might not want to do. I think it's a pretty good idea for the first few tries, but if you totally understand why this is equal to X, then it's fine. Okay, so let's try another one. Now, this is like one of the problems I wrote here, but I'm not even going to refer to it to avoid confusion. See if you can solve that with the symbols on any numbers. Okay, now one thing that's very easy to do here is to focus on the idea that we got to divide by A in order to isolate X. But you can't just divide this by A. If you're going to divide both sides by A, you have to divide this whole side by A and this whole side by A. Okay? And I'll do that in a minute. That can work, but it's a little more complicated. Okay? The easiest thing to do is usually to start by getting rid of an addition that's in your way or subtraction. Okay? Kind of like the order of operations, but in reverse. In other words, you got a multiplication here and an addition here. If you had an expression with multiplications and additions, you have to do the multiplication first, then the additions. In this case, we're going to do the reverse. We're going to do the additions first and then take care of the multiplications and divisions. So we're going to do AX plus B minus B equals C minus B. Then, since B minus B is 0, we get AX equals C minus B. Now, if we divide both sides by A, we're going to isolate X, and that's all we're going to have on this side. So we do AX divided by A equals C minus B divided by A. And AX divided by A, just like up here, is going to give us X. And we get C minus B over A. Now that's, if we look at it, what do we do over here with the numbers? We subtracted 7 from both sides, right? So we wanted to get rid of that number first before we divide by 2. If we could do this, AX plus B plus C, AX plus B over A equals C over A. Okay. Now, what's that mean? That means AX over A plus B over A equals C over A. You see, we still got a lot of denominators here, and we've got to deal with it. It's a little messy. If you keep your wits about you and do every step in a valid manner, you can still get to the solution. It's all that hard, but why go to that trouble when we do this? Well, AX over A gives us X. We still got the B over A here and the C over A there. What do we do next? Well, we've got a plus B over A, and we've got to get rid of that. So we subtract B over A from this side, and then of course we've got to subtract it from this side. Okay, so we get X equals C over A minus B over A, which is the same thing we have here, except it looks a little different. That would be C over A minus B over A. Usually we're going to want to write the thing in simplest possible form with a numerator and a denominator. But we've got the same denominator. We've got a common denominator here, so all we got to do is subtract, in this case, those numerators. And we get this, which totally agrees with what we got there. But this is more complicated, okay? And for that reason, I say get rid of additions before you try to deal with multiplications or divisions, okay? Okay, so let's try another one. Let's try, see some different letters. Let's try S times X minus T equals U. Okay, so this one is fairly straightforward, and everybody more or less got it right. Okay, one little confusion in the first step that I saw, kind of, and following steps were real good, and then one little confusion in the last step. But other than that, I saw a lot of steps, and it looked really pretty good. So use the distributive law here. You get Sx minus St equals U. The one mistake I saw is somebody wrote this as Xt, which is real easy to do since S and X sound almost similar. But you know, it's just like I messed up twice and not writing out negative signs. It's real easy if you're trying to go too fast to make that sort of mistakes. It's not a terrible mistake, although it leads to completely wrong answers. You know, on the open math, if you'd have done that and written out the solution that you got, if that was an X, I'd look at that and I'd say, how in the world did somebody get that? Okay. And then I might ask you, I might just suggest, hey, you want to send me a copy of your work on that so I can see what you did? Usually I can spot what you did and I can give you a little note on it. Okay. But if you make that mistake in the first, X here instead of an S, then end up solving for S instead of X. I've got a good imagination, but it's not that good. Okay, I can't figure out what you did, even though it was a very minor error at this point, and all the rest of the steps were right. Okay, anyhow, there we have it. Now, what do we do? Well, we're trying to isolate X. Right there it is. And everybody understands this now. It looks real good. Most people got to this step. Okay. Anybody that didn't misread that as an X. Then we get Sx equals U plus St. And then we divide both sides by S. Okay. Now, at this point, somebody decided that S would divide that S. But that S also has to divide that U. So you can't divide this S into this, and you can't cancel this with what to do. Okay? Now, you could say that's U over S plus ST over S. And ST over S is equal to T. So that's U over S plus T. I put that in kind of parentheses. You don't have to do that. That's a perfectly good solution. But so is this. Okay. And when you're solving the formula, a lot of times you make decisions about what form you want the answer. Okay. Depends on how you're going to use it. That might be the best way to apply it. This might be the best way to apply it. So you should understand it to be. And of course, then I didn't write out the next step. The next step would be X equals, and then whichever form you want. I didn't leave myself enough room there. I think we understand that okay. So let's do one more. And notice that this is the same form as this equation, right? Okay. Let's say we got an H times R minus B. The letters we use really don't matter. The operations are going to be what they are. And if I replace those with A's, B's, C's, D's, and E's, still be same steps. Okay, very good. Everybody got that right. And I didn't look closely at all the steps, but I saw a lot of steps. And all the steps that I saw looked good. Okay, so I think everybody very likely followed all the steps and did it correctly. You wouldn't be likely to get the right answer if you hadn't. Anyway, let's look here now. First, we distribute the G. And we distribute the multiplication by H. And we get this. And I didn't say what to solve for. But I think everybody solved for Q, which is what I intended. But I should have said it. Okay, so we're going to solve for Q, so we're going to add the GW to both sides. And everybody recognizes this, because everybody got it. And so now we have this, which again, everybody's gonna recognize. So we have this. And of course, the G divides the G, ending up with Q. Equals HR minus HP plus GW over G. I'm gonna leave it at that. That's generally the form we want, a numerator and a denominator, okay? Very good. Okay, well, there are a lot of formulas that come from geometry. Like, for example, you've got a rectangle. That's an L. This is a W. Okay. How would you get the area of the rectangle? Can you write out the formula for the area of the rectangle? Okay, everybody either got that right or was close. Let's review why the area of a rectangle is what it is, okay? Let's say this is 2 by 3, okay? Then we could cut it in half this way. There's 1, 2 halves, right? And we cut it in 3 parts this way. 1, 2, 3 here. Now, how many little squares are there? 6, right? 2 times 3, because there are 2 in a row, and if there are 3 in a row, and there are 2 rows. And those are unit squares. They're 1 by 1 squares. Fair enough? That's just kind of review. So what do? We multiplied the width by the length, right? Usually it's written as length times width. Now somebody wanted to put a half in front of that, and I'm gonna make use of that, okay? But half doesn't make sense if you just think of a 2 by 3 rectangle and think of what the area means, right? How many unit squares could you put into that rectangle? Okay. So what's the area of the shaded triangle? Can you write out what that would be? And I really can't tell whether I'm recording the bottom of the screen or not. I tend to think I am, but just in case. Here we go. Okay, so let's see what everybody thought. Okay. Now we've got 2 formulas for the area. So I'm going to call this A and put a subscript REC on it for rectangle. Well, I can't read that, but I can do what I want with the notation. Okay, that's the area of the rectangle. So now I can say area TRI for triangle would be 1/2 LW. Okay. Now, I've got another triangle. It's a right triangle, so that's a right angle. And that's a B, that's an H. You can print them if you like, it's okay. So what's the area? Okay, now I'm seeing some formulas that involve things from other geometrical objects, like I saw a pi in one of these, okay? And pi is great, we're gonna get that in a minute, because it's very useful for circles. But right now, let's see why this is what it is. That's the right triangle. Then it looks like I can add another square for another triangle. Up here, right triangle. Okay, it's also got dimensions B by H, right? Okay. So that this triangle is half of this rectangle. Got to be 1/2 B times H. Okay. Very similar to what we saw down here. The reason for the 1/2 is the same as the reason. The reason for the 1/2 here is the same as the reason for the 1/2. Okay. They're right triangles. You can put two of them together and make a rectangle. And the area of the rectangle is that by that. Takes two of them to make the rectangle, so the area of each one is half of that. We need more room to do this. Like, or maybe back to that. One, okay. Parallelogram. Turns out I'm going to call this B. I'm going to call this H. H is measured perpendicular to the base up to this vertex. So H is an altitude. Okay. What I'm going to do is I'm going to say, well, I can extend this out here a little bit. And I can make a triangle over here. Now, this triangle has the same dimensions as this one. Which means if I take this triangle and slap it on here, then what I've got is a rectangle. Okay. It actually, you know, the way I did that probably is the best way to do it. So I'm going to make it a little simpler. Let's think it clearly. Okay. I can take this triangle here, which has the same height, because these sides are parallel, so this is the same as this. But I take it and turn it upside down and put it over here. And that gives me the yellow rectangle. Since I could do this. I had a pair of scissors, I could cut this off, bring it over here and slap it on there, and you have a rectangle. Okay. There is B times H. That makes sense? Whether it makes sense or not, that's the formula. There's a reason for it, and you're better off understanding the reason than just remembering the formula, because it's easy to remember a formula wrong. Okay? And there are a bunch of formulas. If you remember the reason for the formula, generally better off. Well, are there other figures? And in the assignment on geometry, which I don't think is due right away, I think it's due later this week. I'll double check that. I'm wrong about that. Well, I'm not. I'm sure it's not assigned to later this week. Some of you have already done it because it used to be assigned too early. Okay. And everybody's done it. I did forgot it right. Okay. Right there is a beautiful circle. It looked good to me from that angle. If I look at it from here, it's a little lopsided. It's supposed to be a circle. Circle of radius r. They've also got a diameter, which I can indicate. And let me kind of make sure we know which one's a radius and which one's a diameter. There's a simple formula connecting diameter and radius. Diameter is twice the radius. And that should be pretty obvious. You should be pretty familiar with that. Okay, so we got a circle of radius r, diameter d. D is equal to 2r. Circumference. Well, pi. Is defined to be circumference over diameter for a given circle. And that's the same for all circles. No matter how big or how small, the circumference is pi times the diameter. So we could say pi equals C over D. since pi equals C over D, well, how would you solve pi equals C over D for C? See if you can write out the steps. Okay, now I noticed somebody replaced pi by 3.15. Actually should have been 3.1415926, and then an infinite number of decimals after that. Okay, so when we have pi, we're going to keep it as a symbol because you can't write it out. Then at the end, you can approximate the answer with 3.14. Okay. Okay, so we don't want to replace pi by a number at that point. But this is a little tricky. Okay, even trickier if you want to try to solve it for D. You're going to solve it for C. And the steps are really simple once you see them. You got pi equals C over D. What can you do to both sides to isolate C? Think about it for a minute. If you do this, well, I'm going to pause for a second. Give you something to think about. Anybody see? Don't say it. If you think you see it, indicate no pause and make sense. Any ideas? Okay, I don't see anybody jumping up and down. We're going to move on. Okay. What can I do to C over D if I just want to end up with C? It's going to be a capital C or lowercase d. What's C over D times D? Well, D divides the D, leaves you with C, doesn't it? So if I come over here, multiply this side by D, this side's going to simplify just C. And of course, we can flip the two sides around, same thing. Okay, and there it is. Okay, well, that's the formula for the circumference of the circle. Now, of course, D equals 2 pi r. D equals 2r. So if we replace D by 2r, we get pi times 2r, which we usually write 2 pi r. All right. That's kind of important to have some understanding of that. Okay, well, it's just one more thing I want to do. And I'm going to do this. On the flyage true, because that gets a little more complicated, although I think you could probably understand it if we spent some time on it. But in this case, okay, there is pi r squared. Now, it's really easy to confuse this with this. Because look, we've got a 2 and a pi and an r here, and we've got a 2, a pi and an r here, but in different positions, right? In this case, r is being squared. Okay. Notice when we decompose the rectangle into unit squares, each square has a unit of 1 square unit. Area is in square units. Now you can't divide a circle up into squares. Okay. It can't be done, although you can do a bunch of successive approximations. There's an easier way to divide the circle up that shows why this is so. But we're not going to do that. Okay. There are other things we need to do. What you need to understand is that area has to be in square units. So the one with the R squared is the one that's the area. And circumference is just a multiple of diameter or an equivalent multiple of radius. Because that's how pi is defined, and it comes back to understanding this. And if you understand that, it's really good. You're less likely to confuse the formulas, and you're going to have a deeper understanding of the mathematics. Now, there are a couple of other formulas we'll talk about after the assignment is due. But these are formulas you can solve just like formulas we have. So when you do the assignment on formulas, a lot of the formulas are going to come from geometry, even though we haven't done the geometry section yet. Okay. Now, if you want to go ahead and do the geometry section, I think it's pretty easy. Okay. It wouldn't hurt you to go ahead and do it, and then you understand better what the formulas mean. But we want to do formulas at this point, and we'll pick up the geometry later in the week. Okay. Because right now, we've done linear equations, you're doing well with it. We want to use the idea of show your steps, do the steps, do correct steps, know what the steps can be, apply it to formulas, and then we'll do the geometry and see what the formulas mean. Okay. You're doing real well. I noticed that not everybody has done the open math assignment. But you know, you did pretty well with the equations, and that was the assignment. So, yeah, you're going to be tested over it. You're going to go to the late assignments page and work through. Go ahead. I'm going to skip. It's probably not going to hurt your grades significantly because most of your grades on the test anyway. Okay, so you don't really need it. Okay. Well, I don't recommend skipping assignments as we get further into the course. Okay. Make sure you practice and make sure you get these things down because everything is going to build. Make sure you have the building blocks. So when we get to the later assignment, you have something to build with. Okay. So again, everybody seems to be doing well.